Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Periphery by Full Deck and Missing a Few Cards, and here are the rules. We have Sudoku, cages, and arrows. Which is standard Sudoku rules apply. The digits 1 through 9 appear in every row, column, and box. We have cages, where digits add to the total in the top left corner of the cage, if given, and digits cannot repeat in cages. So these 4 digits add up to 11, these 4 add up to 17, these 3 add up to 12, these 4 add up to 29, etc., etc. So as an example, we'll use this one. This could be 3, 4, and 5. And that would be valid because these 3 digits add up to 12. And there are no repeats. What you could not have is something like 3, 3, and 6, because though this adds up to 12, you have a repeat in the cage, and that's not allowed. And finally, we have arrows, where digits along the shaft of an arrow sum to the value in the attached circle. So these 3 digits must add up to what this digit is. So you could have something like 332, and this would be 8, and that would be valid. Or even 333, and this is 9. And that is a valid arrow. So while you can't have repeats in cages, you can have repeats along a shaft of an arrow. And as a shout out, for more of our puzzles, this is Full Deck and Missing a Few Cards, please visit missingdeck.net. And Full Deck and Missing a Few Cards they do a very good job of creating good puzzles. So if you enjoy this puzzle, check out their website at missingdeck.net. Those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. The ones that speak out to me are the 4 digits adding up to 11 and the 4 digits adding up to 29. There's only one set for each of them that basically adds up to 11 with 4 unique digits and 29 with 4 unique digits. And that is 1, 2, 3, 5 for the 11 and 5, 7, 8, 9 for the 29. Therefore, we know this is at minimum a 4. And since this is at minimum a 4, this is at minimum 3, this is at minimum 1. This has to be 8 or 9 at least, right? This adds up to 1 and 2 possibly, and then this adds up to 1. So since this is at minimum 3, because it's 1 and 2 at minimum, and this is at minimum 1, this has to be a 4. Because if it's not a 4, the problem is that what's the other option? It has to be 6. And 6 plus 1 and 2 already adds up to 9, which is already the maximum you can have on a single digit. So that would be 9 plus 1 then, which would be 10. So this has to be 4. This is either 1, 2 or 1, 3 here. Right? This can be at most 4 because this is at least 1. So this is 5 here. Therefore, if this has to have a 1 here. This is 1 or 2. We don't know. And then because we know in the upper left-hand box, the 1 has to be in rows 1 or 2. In the central upper box, we know the 1 has to be in rows 1 or 2. The rest of row 1 and 2 cannot contain a 1. So this must be at least 2, 3, 4, and some other digit. But you have the same problem here, actually. The 2 we know in the upper left box must be in rows 1 or 2. And so must the 3, actually. We know 1 out of 2 or 3 has to be in column 4, shall we say. In this arrow, basically. Has to be in rows 1 and 2. So either 2 or 3 cannot be in the rest of rows 1 and 2, which means it cannot be in the 17 box here. If that's the case, so this can't be 1. This is at least 2. This could be 1, and this could be 1. So this is at least 4. This could be 2 through 7. And this is 1 through 7, but no 4. And this is 1 through 7, but no 4. Because it could, this can't be, no, these can't be 7, because this is at minimum 2 and 1 for the other digits, right? Can you have a 2 or 3 here is kind of a question, right? If this were 2 or 3, that means 1, 2, and 3 in the upper left-hand box have to be in rows 1 and 2, and 1, 2, or 3 in the upper central box have to be in the first 2 rows, which eliminates 1, 2, and 3 in the remaining rows. If that were the case, this would be at minimum 4, 5, 6, 7. And that's 22, which is not allowed. So this cannot be a 2 or a 3. Therefore, we know this is at least a 4. So this is 4. That means these two digits must add up to 5 at most. And okay, this could be 4. But this cannot be 4. This is 5 or this can't be 5 or 6. This can't be 5 or 6. Because we know we have a 4 there. And so this is 4, 1, 1 at minimum. So this is 6, 7, 8, 9. We know this must be at minimum 2, 4, and 5. And therefore it has to be 2, 4, 5, 6. Right? Because that's the minimum. We cannot have 2 and 3 here because 1 out of 2 or 3 is here. And we know both 2 and 3 are here. So if both 2 and 3 are here and 2 out of 3 are here. Sorry, 1 of 2 of 3 is here. That means this cannot be both 2 and 3 allowed. It's 2 at minimum with 4 and 5 and 6 as the minimum. And since that's the minimum, that adds up to 17. So this must be then 2, 4, 5, 6, which eliminates 2, 4, 5, 6 in the rest of the box. Also, we know 2 is in rows 1 and 2 in the upper right-hand box. And in the upper left-hand box, 2 is also in rows 1 and 2, which eliminates 2 in the rest of rows 1 and 2. So this cannot be 2. This becomes a 1-3 pair here. 2 has to obviously be one of these, but it cannot be here because that's a sum of 2 unique digits. This is 1 and 3. This is 4. Therefore, this must be 1 and 9 to add up at all. 1 cannot be here, obviously. This is 2. This cannot be 1, and it cannot be 9. So, since we know this can't be 9 anymore, this can't be 7. This is at minimum 4, 1, and 2. So this is at least 7. We have 1 degree of freedom here. This can't be 4 then. This can't be 6. This is 4, 5. This is 2 or 3. And this must be a 1 because we have 1 degree of freedom on this arrow. And what I mean by degree of freedom is you take the largest number, actually you take any number on this arrow. The 1 degree of freedom means you can increase the digit on the lowest digit by only 1 possible on this arrow, right? Because this, at minimum, it's already 7. You can only go up to 8, which means that that's the 1 degree of freedom you have, right? So that's the what I usually say when I'm saying degree of freedom. That's what I usually mean. So this cannot be ever 3, right? Because if you jump up to 3, you have 4, 3, and 2 at minimum, and that will add up to 9, but we don't have a 9 possible. So that's how sort of degrees of freedom work. It's usually used in like diagonals because there's no restraint for, or no constraint for like duplicates. And so you need to use sort of degrees of freedom to figure out what restrictions there are on cells. So again, and the reason why you can do that is, again, you know there's only one degree of freedom because from the minimum to the maximum amount, or yeah, from the minimum to the maximum amount is a difference of one. That's the degree of freedom you have. If again, this difference of degree of freedom here, one cannot go to three because that's 2 degrees of freedom, right? So if you have 4, 1, and 2, that minimum is 7. If you jump to 4, 3, and 2, that would basically increase it to 9, which is not possible because we don't have that degree of freedom. So this must be a 1. We still have that degree of freedom possible, though, in that arrow. So we know this is 1. We know 3 has to be one of these two because 1 and 3 is here, and 3 is here, which eliminates 3 in the rest of the box. Or, sorry, row 1 and 2. We know 1 has to be one of these digits, and 1 is there, so 1 in column 3 cannot be here, and must be one of these digits. Well, this box cannot contain a 1. What's the minimum? It has to be 2, 3, 4, 5, which is exactly 14. So since this cage is the minimum, it matches the amount possible. That means this has to be 2, 3, and 4, 5. Which leaves the remaining digits in that box as 1, 6, 7, 8, 9, right? So this has to be 1, 6, 7, 8, 9. Obviously, this can't be 1. This can't be 1. Where are 2, 3, and 5 in column 3? They can't be here because of the 1, 2, 3, 5 quadruplet in the box. They can't be here because of the 2, 3, 4, 5 quadruplet in the box, so they have to be here. So this must be a 2, 3, and a 5, period. That leaves the remaining digits in this box as 4, 6, 7, 8. Yes. The remaining digits in the upper left-hand box have to be 6, 7, 8, 9, and 9 cannot be here. Obviously, this can't be 9. This can't be 9. Can't be 8 here. It could be 1, 6, or 7. This is the sum of 3 unique digits, adding up to another digit. If you ever have 3 unique digits adding up to another digit, you have to have 2 digits. Well, this can't be 6, 7, or 8. If this is 6, this is at minimum 2 and 3 added with it, which would be 11, which is not possible. So this has to be a 1. Since this is 1, this can't be 1, and this can't be 1. This is 6 and 7 at least, so this must be 2 and 3 at least, right? To add up to 9. This is 2 and 6 at least, so this is 8 or 9. This can't be 9 because of this 9, so this is 8, which eliminates 8 here and eliminates 8 here. This 8 must be the sum of 2 and 6, specifically. So this can't be 6 or 8 here. This is a 7-9 pair. 2 can't be any of these. This is at minimum 1, 3, and 4. It could be 1, 3, and 5 also, but 3 has to be here. So this is 8 or 9 here to add up with 1. Because the minimum is 1, 3, 4. It could also be 1, 3, 5. It can never be 1, 4, 5 because that adds up to 10. We have a 4, 6. Okay, this 2 eliminates 2 here. So that makes this the 3, 5 pair. This can't be 6 because of the 6 in the column. This 3, 5 pair eliminates 3, 5 in the rest of the box and the rest of the column. So this can't be 3 or 5. This must be 4, which forces this to be 5 and this to be 3. So this adds up to 8. This 3 in the corner, we celebrate because we know we're getting close to solving it. This 4 eliminates 4 here. We know this in column 3, the 8 has to be in one of these two cells, so that eliminates 8 here. This can't be 8 because of the 8 in the row. Yeah, I'm not sure if this is the best way of approaching things, but anyways. If this is 6, maybe this one would have been better. Anyways, let's just continue. This is at least 3. This is at least 2, right? This is 1 and 2 at least. This is 2 at least. So this is 3 plus 2, which is 5, plus 1 is 6. So this is at least 6. And we have 3 degrees of freedom here. So as a minimum, we have 1, 2, and 1, 2 here. This can't be 1, this can't be 2. We have 3 degrees of freedom. So this can go up 3 and 4. This can go up to 5. This can go up to 5. But we can't have a 5 in the box because of the 5, 7, 8, 9 quintuplet. 1 cannot be here, so 1 has to be one of these 2 digits in the lower right-hand box. The rest of row 7 is 1 through 6. So this is 1 through 6, but no 5. This is then 2 through 6, because 1 has to be one of these. And 5, where is the 5 in row 7? It has to be here. So this can't be 5 here. This must be 2. And it can't be 1, 3, 4. And again, we have 3 degrees of freedom for any cell in this arrow. So this is 1 through 4 here, because this goes from 6 through 9. So this has to be 2, which means 2 cannot be here. This is 3, 4, 5, or 6. Cannot be 3 because of the 1, 3 pair in the column. We know 2 has to be one of these 3 digits here because 2 is here. What else? These digits cannot be 5, 7, 8, or 9. So no 5, 7, 8, 9, no 2, 4, 1, 3, no 1, 2, 3, 4, no 5, 7, 8, 9. It has to be 6 here, which eliminates 6 here. So 6 and 5 have to both be here. This must be 5, 7, or 9. 5 eliminates 5 here. Where is the 5 in... well, this 5 here eliminates 5 here. So this is 7 or 9. This can't be 2, 1, 2, 3. It could be 5. Okay, so the digits on the arrow sum to this digit here. So if this digit is 6, this would then have to be a 5. If this digit is 7, that means this is 4. If this is 8, this has to be 3. Same with this. So this can be 5 through 9, but no 8 because of the 8 in the column. 6 has to be one of these 2 digits here. So this can't be 6 either. So this is equal to the sum of these 2 digits. Actually, it can't be 5. If it's 5, this would have to be either 1, 4 or 2, 3. The 1 is obviously in the row. If you had a 2, 3 pair here, that would eliminate 2 and 3 here. So this can't be 5. This is 7 or 9. This must be the sum of these 2 digits, which is equal to that, minus 12 minus that, right? So this cannot be 2. It would have to be 3 if this is 9, or 5 if this is 7. Well, it can't be 3 because of the 1, 3 pair in that box, so this must be 5, which makes this 7. Therefore, that leaves us as 2. The 7 eliminates 7 here, so this is 6, this is 9. This can't be a set 9 because of the 9 in the box. This 9 eliminates 9 here, so this is 7, which makes this 9. None of these can be 7. This 6 eliminates 6 here. Since this can't be 7 anymore, these can't add up to 7, so you can't have 4 added with that. So this is 3 or 5 here. And it cannot be 3 because of the 1, 3 pair in the column, so this is 5, which makes this 6 added to with this. Therefore, it has to be 2 and 4 specifically. That 4 eliminates 4 here. Therefore, this is a 1, 2, 3 triplet, which eliminates 1, 2, and 3 in the rest of the row. This has to be a 5, 6 pair here. This 4 eliminates 4 here. This 2 eliminates 2 here. And we also eliminate 6 here because of the 6 in the row. We still have 3 degrees of freedom because this adds up to a minimum 6. This 5 eliminates 5 here, so this is 4. 4 cannot be here. This is a 3-8 pair, because that's the only digits remaining in row 3. We have a 7-9 pair here. And this must be a 4 here, because that's the only digit remaining in this lower right-hand box. So this is 7, which means this is 2 or 5, 1, 6, or 3, 4. It cannot be 1, 6 because of the 1 in the row. Can't be 2, 5 because it shares a cage with the 5 already, so this must be 3 and 4, which eliminates 3 and 4 in the rest of the row. This can't be 3, this is a 2. So this 4, 1, 2 adds up to 7, which means this can't be 7. This 2 and this 3, 4 pair eliminates 2 and 3 here, so this must be a 5. This 2 and 5 here eliminates 2 and 5 here, so this is 3. Okay, this 4 eliminates 4 here, so that's a 3, which makes this 4. 3 eliminates 3 here, so this is 1. 5 eliminates 5 here, so it's 6 and 5. Can this ever be 1? If this is 1, this has to be a 2 or 3. So this would add up to 6 or 7, but that's not allowed because of the 6 in the row and the 7 in the same box. So this can never be 1 here. This is 3 or 4. This 2 eliminates 2 here. Let's see. This 4 eliminates 4 here. So we have in row 2, we have a 2, 6 pair, which eliminates 2 and 6 in the rest of the row. This can't be 2, so this must be 1, which makes that 2. This can't be 2 or 6 because of the 2, 6 pair in the box. So that becomes 4, 5 pair. The 4, 5 pair eliminates 5 here. So this is a 3, this is 5. This 3 eliminates 3 here, so that's 1 and 3. Where can 6 be in this upper central box? Can't be here because of the 2, 6 pair and the 6 in the column, so this must be 6 here. This has to be an 8, 9 pair here. That's fine. This is 7, 8, or 9 here. Where is this 3 in this lower central box? It can't be here, can't be this digit, so this must be a 3, which forces this to be 7 or 9. But 7 can't be here because of the 7 in the column, so this is 9, this is 7. This 9 eliminates 9 here. This 7 eliminates 7 here, so this must be 8, which makes this 7. 8 eliminates 8 here, so this must be 9. This cannot be 9 here. This can't be 7 or 9, so this must be 5, which forces this to be a 9. 5 eliminates 5 here, so this is 4, this is 5. 2 eliminates 2 here, so that's 6 and 2. This must add up to 9. It's either 2, 4, or it's 3, 3. We're not sure which right now. Remaining digits in column 4 are 2 and 6. 2 cannot be here because of the 2 in the row, so this is 6, this is 2. That leaves an 8 remaining in row 4. This 6 eliminates 6 here, so this is 8, which means this can't be 8 here. Remaining digits in column 7, we have 2, 3, and 5, and this can't be 2. So this must be a 3, 5 pair. 3 eliminates 3 here, so this is 5, which makes this 3. That makes this 2. This adds up to 9, so this must be 2 and 4. 4 eliminates 4 here, so that's 7 and 4. 7 eliminates 7 here, so that's 8, which makes this a 9, which makes that a 7. 9 eliminates 9 here and here, so this is 8, this is 7, this is 8, this is 7, this is 9. 8 eliminates 8 here, so this is 3 and 8. This 3 and 2 eliminate 2 and 3 here, so it's 1. This is 3. Remaining digit here is a 6, which makes this 1. This has to be a 9, which makes this a 1. And that's how you solve it. Yeah, I hope this was clear about what the degrees of freedom. Degrees of freedom is very useful on diagonals where you don't have like limited sets. It also can be useful in like some types of cages where they don't have the restriction on repeats. That's a pretty rare clue set though, so that's not the most common. but it's usually used for a lot of diagonal stuff because if you have things in rows and columns and boxes, in the same row, column, and box, you're limited because you have to have unique digits on those. But along diagonals, you don't have to have unique digits. So it's much easier to use the idea of degrees of freedom that you have, right? And so we were limited by these degrees of freedom here because the digits, first you look at the minimum. You can also do this for a maximum amount too, but usually it's easier for minimums, or you usually find it for minimums because you have stuff like arrows pointing to a adding up to a single digit. Um, that limits things a lot on what can be on the arrow, right? And those degrees of freedom essentially restrict the cells on the arrow from what they can be. Anyways, I hope that made sense, and I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.